Hey, Total Physics. Today we're going to talk a bit about comets, what they are, what they have to do with energy, and yeah, I hope you enjoy it. We're going to deal again with comets and orbits and stuff when we get to the chapter on gravity, which is not so far away from what we're doing now. Okay, let's begin. So, what is a comet? Raise your hand. Oh, okay, good. Um, Comets. Well, you probably heard of asteroids, right? Asteroid, big chunks of rock that might, well, they orbit around the sun. And if we're unlucky, one will become a meteor, and that means it's come into the Earth's atmosphere and then hits us. Ow, bam. Okay. If you ever been to Arizona, there's a great meteor crater there, and that it's pretty impressive. And even some pieces of the meteor you can see it was a metallic meteor that hit Arizona a long time ago. Yeah, one has hit Russia in the taiga a couple hundred years ago, knocked down trees for like miles and miles and miles in every direction. It was pretty interesting. Nobody lived there, but they figured out what did it. Comets can do that too. Comets can hit the Earth. Um, what are comets? Well, asteroids are rock. Comets are ice, dirty ice. Dirty ice balls. We're talking like kilometers across. They're not small. Same with some meteors can be big too, although some can be smaller. But for comets, basically, they're a number of kilometers across. They're dirty ice balls that orbit the sun. You might say, well, so what? The Earth orbits the sun. What's the big deal? Okay, so here's the sun. Today we get a red sun because I don't have any other color. I don't have any yellow. And here's the Earth. Now, this is not to scale or anything like that. Earth has a very round orbit around the sun, right? It's boring, and it's a good thing it's boring. We'll see why later. Comets go way out there. So what they do instead of Earth, there's Earth. Let's make our comet blue, like icy blue. Comet's orbit, instead of being circular, is very much like an oval. We'll see what the fancy name is, and you might be studying those in math this year anyway. So it goes way out past Pluto, and comes back. So draw yourself a big old orbit out there. And again, this is not to scale. This goes way out to what's called the Kuiper belt. Kuiper. You don't need to know that. Way past Pluto. Way out there. And the time, like, okay, how long does it take Earth to go around the sun? 1 year, right? Okay, right? Earth, sun, 1 year. Comets take decades to hundreds of years. A couple of them they've found take 200 to 300 years to go all the way out and come all the way back. The most famous comet is called what? Halley's Comet, named after a guy who studied astronomy and comets in particular. Halley's Comet, the time to go around once is 86 years. Wow. Okay, what does this have to do with energy? Well, we're going to draw the comet at some spots here. We're going to draw the comet heading out. We're going to draw it out here. We're going to draw it coming back. We're going to draw it getting closer to the sun. Now, when it gets closer to the sun, of course, shines on it. And what's it do with it? Well, it melts it a bit. And as the comet keeps moving, it gets what's called a tail. So here's our comet. And as it's moving, it gets like a tail. And as it gets really close to the sun and swings around, the tail gets really long. Remember, this is moving, okay? So the tail's behind it, right? Think of like a fluttering tail behind it. The tail is mainly made of like vapor, water vapor, and vaporized dust. And it goes around. And it goes further out here, and of course, it loses the tail. Well, some comets probably disappear and totally melt out, but a lot of them seem to go way out here and come back time after time after time after time for many, many times. We don't know how many times. Um, Comets are discovered every once in a while by somebody just looking up into the sky. Often it's an amateur astronomer and finding something up there and watching it move over the course of days. And it's a comet, and it's one nobody's seen before. Why? Because maybe it last visited the Earth 200 years ago or more. And some comets are visible to the naked eye, some are not. I've seen a couple in my lifetime, and they're really cool, and you can see the tail and stuff. I hope you get that opportunity. You'll get to see Halley's Comet, I hope. It came during my lifetime, and it was really boring. It did not put on a good show. 1910, it came, and everybody saw it almost during the day. It was so bright. And I hope you get the chance when you're like 50 or 60 years old, you'll see Halley's Comet. I hope you're around that long. I probably won't be. Okay, so what does this have to do with energy? Well, let's think about what's driving this comet, okay? What's pulling the comet towards the sun? Gravity, right? Okay, that sounds like a certain type of energy we know, right? Okay, where do you suppose the where do you suppose the comet has the most amount of potential energy? Well, I hope you guessed way out here because it's really far. Think of like something held up. PE, more PE, right? Remember, if we increase the height, well, if I increase the distance for the comet, it's got a lot of PE out here. Where's it got the least amount of PE? Close to the sun. So I'm going to write a little bit of PE here. Where's it going the fastest? The highest velocity. Turns out, right by the sun. Really whipping when it comes around the sun. In fact, we see it for a few weeks. That's it. And then by the time it gets past the Earth, it slows down and it's out there for years, decades, hundreds of years. Crazy, huh? Really slow out here, really fast here. So where's the kinetic energy the highest? Yeah, right by the sun. So Ke is small, sorry, Pe is small, but the Ke is really big. I'm going to write Ke in big letters. Where's the Ke the smallest? Out here, right? So this is all about what? It's all about the transformation of energy, and it's a cool natural example. Remember the law? We can't get rid of energy, we can't create it, but we can transform it. Where's it got about half Ke and half Pe? Yeah. Anyplace else? Yeah. Okay. Remember, it's going this way. So I'm going to just put, well, okay. And on the way out to here, it's changing what energy to what? Here, I'll write half Ke, half Pe. Same up here, half Ke, half Pe. But But on the way out here, it's changing what to what? Well, what's bigger? KE changing to P. So on the way out, it's got like this going on. KE changing to PE. I guess I'll use a cap. Anyway, just put a capital there. It doesn't matter. On the way back, it's changing what? PE2 to KE. Here, if that bugs you, I'll change that. Okay. Here's my icy comet. Ready? Here it goes. Wow. 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 You get the idea? It's going really fast here. It's going really slow out here. In fact, I can't even show it. It's going so slow out there, and it's going so fast here. Comets are a perfect example of the transformation of energy. Good. That's it. We'll do a lab having to do with the shapes of different orbits, but that'll be a couple weeks away. Okay. I'll be back a week from Friday, and I hope to see you then. And I'm well, so don't worry about me, and you stay healthy too, huh? Okay, total physics. Good day.